All right. Okay, folks, we're going to get started. If you're at the back of the room chatting, then come in or go out or whichever. Okay, so this is the Lake Working Group. This is our first meeting as a working group. My name is Stephen Farrell.
And I'm Alicia Ortonich.
So we're here to help. We have those slides. We have two people taking notes on Etherpad and a JavaScript. There's the note well. Here's the agenda. Anybody want to bash the agenda? So just to explain, I think John's presentation is probably the meatiest bit, and it comes in kind of two parts. He's got about 6 or 7 slides at the beginning, just kind of providing context and background. If you can kind of just keep it to clarifying questions for that bit, that'd be great. And then there's one slide that says discussion. Just before we get there, we'll do a home to see if the people in the room would like to adopt that draft, confirm it on the list obviously later. And then we can go on to discuss the details of the requirements and comments people have on them, if that's okay. So any other agenda bashing? I think Michael Richardson had to be in the Anima working group, so Militia is going to just present a couple of slides he gave us. Is that all good? In that case, John. Now, let's see what happens when I hit this button. Do you want a clicker?
No. Yeah. So this is a presentation on the lightweight AKA for OSCOR requirements draft. It's now in version 3. It has been updated twice since the last IETF as the boss. So what is Lake? And this presentation I was been asked to try to not repeat the discussions from the SEC dispatch interim and to the BOF, so it will be quite little about radio protocols. Background, Lake is about specifying a lightweight authentication key protocol for OSCOR, and lightweight is really the important thing here. If we don't do it lightweight, it will not work well for 6-dish and LoRaWAN, and then we have failed. Requirements for lightweight is following what is constrained environments defined in RFC 7228. What we need to discuss here is how do these constrained environments apply to an AKA, and especially which radio technologies, which type of devices. So this is not a new, this is the first working group session, but it's not a new subject. It has been discussed in ACE, it has been discussed in 6- dispatch interim. There was a BOF, and it has also been discussed in other group, for example, extensively in 6-dish. So the requirement draft, we have added a lot more material for basically the different areas of requirements. We also try to make the requirements more strict and more specific. There's still things to do, but I think this is a good start. We're covering I think we're covering the areas that should be covered. And I think there's these 6 type of things. I will go through them. There will not be a much, lightweight is very important to radio technology, but that will not be repeated here. So first, so Lake is a key exchange for OSCOR. What does that mean? It means that it needs to provide what OSCOR needs. So if you don't know that, OSCOR is a security protocol for co-op. OSCOR needs a master secret, and that should have good properties. Oscar already have key exchange without Diffie-Hellman, so this AKA should provide PFS. Oscar also need sender IDs, which is identifying the endpoints. And then Oscar needs some COSI algorithms. Oscar is built on COSI, it needs COSI algorithms to operate. Then the AKA shall reuse CBER, CoAP, and COSI. What this boils down to is that it should not add too much code and complexity to implementation. Ben?
Ben Kadek, sorry, just to clarify, when you say that OSCOR needs COSI algorithms to use, that just means it needs to know which ones to use.
Yes, exactly. Needs an identifier or something, yeah. And I think the current version of this requirements documents have too much shall. There will be further discussion should be which of these are really should, and maybe some are may, depending on the trade-offs. The AKA should be able to, yeah.
This one is the OSCOR sender IDs. If I remember correctly, that's the way to associate the security context. It's of the OSCOR.
Yeah.
True? So there's two in different directions.
Yeah, similar to the connection IDs in
okay.
your, yeah. Should support the same transport, CoAP, and Lake should not spend time duplicating functionality that is already available in CoAP, such as packet loss, reordering, duplication, fragmentation, and denial of service protection. Mohit?
Hi, Mohit. So maybe it's on the following slides. I'll ask anyway. So is it on purpose that it doesn't say how is the key exchange authenticated? Are you planning to support RPKs, PSK, certificates?
Yes, I'm coming to that on later slides. Next type of properties is authentication, credentials, and crypto properties. And we believe that it should support mutual authentication, I think is a requirement for IoT. We think the AKA needs to support PSK, RPK, and public key certificates. There's been a request on the list that it should, the AKA should support different public key credentials for different endpoints, i.e. one endpoint authenticates with a certificate and the other with a RPK. I think it was Michael Richardson has also come up in discussion earlier. Should also support any IoT ways to identify these credentials. This list, the list of what is currently available in has been discussed and is on the way of being designed for COSI. AKA shall support identity protection, definitely here for public keys. Little bit different protection for practical reasons for the initiator and the responser. It would be good if the AKA supported identity protection for PSK. This comes with a lot of trade-offs, so it might not be worth it in the end, which Ecker pointed out on the list today. And that is part of the discussion later today. The AKA should support negotiation. Yeah.
This is Hannes. I was wondering about one aspect that came up in CFRG not too long ago, namely the use of password-based strong authenticated key exchanges, which people there also proposed as a need for IoT environments. And it didn't came up in that list, and I thought was it an intentional omission or?
I don't know. It has not come up in these discussions. The use cases we have seen in 6 editions or not, it has not been a requirement. I think it's mainly used for maybe home deployments. So it's for further discussion if you think that should be included. It's not included in the requirement document right now.
Dan Harkins. Are the public keys in these certificates and the trusted RPRK, are they like a certified Diffie-Hellman key or a certified signature key? Do you can you do a lake without doing a DSA, for instance? Could you do it with just Diffie-Hellmans?
I think so, and yeah, and that's for further. That is in the discussion at the end.
It's
I
not a
think,
requirement, though.
yeah.
Okay.
I think,
But I'm
yeah.
wondering if that's a requirement. It's not a, it's
So it's,
a nice to have.
you might repeat what Richard said off the mic, or Richard could do that, I guess.
This is Richard Barnes. I just said that it is possible to, in fact, to build aches that only use DH keys and not signing.
Yeah.
Yeah. I think more using the Diffie-Hellman keys probably come from limiting message size rather than requirement that somebody only has that and can only use that. Yeah. The AKA needs to support negotiation of algorithms for OSCORE and for the AKA. Has been pointed out, people wants to be able to change algorithm during the lifetime of their devices. And the negotiation selection should be protected against downgrade attacks by man-in-the-middles. More crypto properties. Compromise of the long-term keys we need to protect against. Should an attacker compromising the long-term keys should not be able to compromise past session key, so-called perfect forward secrecy. Should also protect against passive attacker compromising future keys. Should be forced to be active at least. The AKA should provide key compromise impersonation. So if you take the initiator's key, he should not be able to, the attacker should not be able to authenticate as the responder towards the initiator. And then the AKA should provide about against misbinding attacks and reflection attacks such as the selfie attack. Yeah.
This is a little nitpicky, but I noticed this in the document too, and I should have commented. The selfie attack actually had two variants, right? One was a straight up reflection attack, and the other was when you have multiple endpoints with the same key material. They both act as client and server, right? So are you saying both or just one?
Only two-party. Right now, there has been no suggestion to expand this to multiple parties having a PSK, so two-party PSK. Yeah.
Right, because to my knowledge, the only way to fix that attack is to have asymmetry between the client and server roles for the key.
I think you can have roles. You could forbid simultaneous connection, or you could check that the reflected messages are not the same.
No. As I say, that's what I'm saying is so the selfie paper, right, describes a setting in which you have two settings, right? One in which you are reflected back to yourself, and the other in which you have two endpoints, each of which can act as client and server for the same key. Say you have like a VPN gateway that's got clustered across two boxes, right? Yeah. And so you're right that for the reflection attack, you could stop that by comparing one of the nominally random values. But for the sort of crossing attack, you actually have to have, as far as I understand it, something different, because you can't get you have to separate out the key material for client and server and not let people act simultaneously. Anyway, so we can talk about it, but it's probably worth fleshing that out a little more.
Yeah, it should definitely protect against all serious attacks. We need to flesh out what that means.
Mohit, so I was actually going to say the same thing as Ecker said, because protecting against all kinds of selfie attacks, you would need some kind of strong identities, and maybe it might be worth saying that we are protecting against this specific kind of selfie attacks, and we are only considering two-party communication, even though two parties is a group of two. So if you're not going to allow parallel sessions and so on, it should be explicitly in the requirements document at the beginning.
For the benefit of folks that are remote, if you're speaking at the mic, can you just speak your name and roaming to India since I'm saying?
Next type of requirement is on application data. There's been requirements put forward from 60s, among others, to transfer application data in the protocol. For example, authorization tokens. This could also be transferred outside of the protocol, but transferring them in the protocol give benefits, even if it's not protected. And for later messages, it might be protected. So example of this type of application data is authorization information, such as proof of possession tokens, authorization vouchers, could also be certificate enrollment requests. And there's been requests from academia to have strict requirements for this, so you can verify informal verification saying if any protocol fulfills these requirements or not.
It sounds like you have some discussion on this later, but this is actually seems like quite a subtle point to describe exactly what the requirement is, right?
Yeah.
And exactly how it's supposed to be bound to et cetera, right? Is it like in particular as part of the protocol transcript and like, et cetera. So probably have to like really define, like, it's not like carrying it is easy. It's carrying it safely. It's hard.
Yeah. Then lightweight. Lightweight is a big discussion in itself, but as the BOF and SecDispatch interim focused very heavily on lightweight radio protocols, we are not repeating that as now. Main highlights of what lightweight should mean is that it should have few round trips, few messages. If you increase it to more messages, it takes, in some cases, it increases the latency significantly. And two of the radio technologies that has a need for a lightweight AKA is LoRaWAN and 6TiS. LoRaWAN has very small frames, and then it also depends what kind of things do you put in them except the AKA. The number that was mentioned for LoRaWAN was 54 bytes for payload. 6TiS is a bit more complicated. Then the amount of payload depends on the amount of hops. Estimates for 5 hops are similar to LoRaWAN, around 54 bytes. But that decreases for each hop you want to support. Another requirement is processing memory and especially code size. Yes, Francesca.
So from the Jabber, Julian Catalano says actually LoRaWAN can go down to 11 bytes US regulation.
Yeah. Yeah, so 54 bytes is not the lowest LoRaWAN. I don't know if it's possible to support 11. These are just example of constrained radio. LoRaWAN can be even more constrained. You have 6FOX that has 8 byte. There's probably other radio technologies, current and future, that will also be more or less constrained. But the requirements draft has substantially expanded this and tried to put down the information from that was discussed in the BOF and SecDispatch. Richard?
This is Richard Barnes. So I think you may be able to be a bit more specific on that first one. I think all of the candidates one might imagine plugging in here are basically 3-message protocols. So I think focusing the work here on like a 1.5 RTT sort of framework seems like a reasonable constraint to me.
I think messages here more apply to lower layer messages after fragmentation, which might happen on different layers. Yeah.
Mohit, so 3-message protocols work fine when the lower layer is reliable. Bit more tricky to implement when the lower layer is UDP or something. So unless you're going to say it's TCP or something reliable, I am not sure if we can just put the number 3 there.
I mean, DTLS 1.2 is can do 3 messages. I think you can, as long as you have reasonable assumptions about retransmit acknowledgement, you can do it in 3.
So that means that the lower layer is reliable.
No.
So Mohit, can you talk to the mic, please?
So you will do the retransmissions and acknowledgement at the layer of the key exchange then?
Yeah, sure. So basically, I mean, if you look at the DTLS 1.2 design, you can see this, where basically the person who transmitted last drives the transmission, except for the last leg, which is just a tail, and then and so like in the 3 message protocol, the server basically retransmits until it receives the client's message, and then it just stops. I didn't say it's not a pain. I'm just saying you don't need explicit X, right? I mean, you can do it. I'm not saying it's good or bad. I'm just saying it's possible.
I think, in this requirements document, you could make a distinction between like AIK layer round trips, like in other contexts, I would say application layer round trips and like transport round trips. I think we could probably agree that like 1.5 RTT at the logical AIK layer is probably a worthwhile constraint, even if that requires more machinery underneath.
Yeah, on that I agree with Richard.
Valery Smyslov, Willis Plus. Just to add about the requirement for 3 or 4 messages in IPsec ME working group. In IC version 1, we had 3 messages exchanges, and it was a real pain because the retransmission logic was to be switched from initiator to responder for the first message. And for IC version 2, it was switched for the logic that all the exchanges must have an even number of messages for unreliable protocol. It simplifies implementations a lot.
Yeah, I think this can be topic for discussion. I think so far what we have heard from 6TiSCH is that they prefer 3, for example. But there are trade-offs, also other trade-offs than that. For example, PSK hiding and
this is Militia Matar Hetov. Just regarding the 6TiSCH requirement, what you said about 3-pass, we discussed essentially that it would be more preferable to sometimes to have a 4-pass protocol if it wouldn't require fragmentation than a 3-pass protocol where one message would get fragmented into 2 frames.
Then the last slide on AKA frequency. How often is the AKA going to run, which was a discussion topic on the list. I don't remember who raised the question, but that's a good question. I think it's hard to give an exact answer for all devices and use cases. For the most extreme use cases, running a Diffie-Hellman is probably to have it to start with. They are out of scope for Lake as far as I see it. Then you can use OSCORE without AKA. Typically you will run the AKA once during bootstrapping, but then you will probably run it more. Some of these devices are not very stable. They will reboot, and then you typically run them, depending on how much you can save in persistent storage. Hannes?
Hannes, I mentioned that before, specifically if you care about efficiency, then, for example, taking the issue of the recovery and how often you run into account is obviously important. So, for example, devices that don't have persistent storage is often very difficult because where does the code actually reside, right? That hopefully on a persistent storage, it doesn't get sucked in from the network. And also this, when you think about the impact, the key compromise, and that's those recommendations where, and you don't mention them explicitly here, which one you mean, but they often take into account existing work, for example, in web browsers, in other environments where the communication situation is somewhat different, and also the assumptions about where keys are stored, for example, in a browser cache, etc., are also different. So those need to be looked at with a grain of salt, I believe.
So Hannah's, just as a reminder, before you came in, I asked people to try and stick to clarifying questions until after this slide when we'll do an adoption call and then have this kind of discussion. But you hadn't come in then.
Good that I wasn't in here, but when you said.
But we have time, so I'm not, I don't think we need to be strict. We do have time.
Oh, okay. Well, so I mean, with respect to this third point, and this is obviously a sort of security requirement that we struggle with in MLS as well. In terms of forward secrecy key compromise, namely, that is compromise at point T and for data before point T, then it suffices simply to ratchet the keys. It's not necessary to Diffie-Hellman exchange. The Diffie-Hellman exchange is required for doing PCS, post-compromise security. However, I want to be extraordinarily careful with that because unless you're doing basically, unless you're doing like continuing ratcheting over the same connection as opposed to initiating a new connection, you don't actually get PCS because compromise of the authentication keys suffices to screw things up. So I think actually I'm not entirely sure this last point is correct. Richard can probably elaborate more, but I know this was quite an issue.
Yeah, I was just going to say that this is a requirement on the AQ that's going to need a little bit of. I'm trying to look at John, but it's going to need a little bit of precision because just framing this in terms of like existing or semi-existing technology. We're going to need to distinguish whether we need like a session resumption thing, something that's like session resumption in TLS, or something that's like key update in TLS that just hash ratchets forward, or something that's like PCS updates in MLS. Right, because those have fairly different shapes in the protocol, and so understanding which of those ends up as a requirement in this is going to be important.
Yeah. As I understand it, OS Core already supports effectively hash ratcheting, though I'm trying to remember the design. It may not in fact be a hash ratchet, but it supports, I guess, because does it as a master key? I guess you ratchet forward. Is it a ratchet, or is it like more like session resumption? Is it more like 1-2 session resumption? Do you remember?
No.
Okay, we want to sort that out, obviously.
Yeah.
As a reminder, if you can say your name when you go to the mic, that'd be great.
Yeah. So in the reboot scenario, we probably have to assume that there is no state to fall back on. So then hashing solution probably does not work. But that's a very good thing. I don't remember what the requirements document says. It might have to be formulated in more non-Diffie-Hellman terms. The requirement cited here for BSI, NIST, and ANSI is recommendation requirements for IPsec, which they don't remember if it's BSI or ANSI, but for IPsec they recommend doing a Diffie-Hellman every hour. That's not doable for constrained IoT, but probably the constrained IoT should protect their keys. They should do Diffie-Hellman or ratcheting more often than their 10-year life cycle.
Right. So this actually, I think, is like quite an important point, which is that because we're also trying to minimize, bandwidth and computation.
Yeah.
If the purpose is having PCS or Diffie-Hellman refresh in any case, then what you really need is something that smells much more like TLS session resumption, because you want to do just the Diffie-Hellman, but you don't want to incur the RPK authentication cost, the signature or the second Diffie-Hellman, or I guess third Diffie-Hellman, because you got. It's practically like a sigma type protocol, right? Has basically 3 public key operations, as opposed to 1. And so, if what you want to do is key refresh, but you're not concerned about, so you see where I'm going with this, right? So, I think that definitely we need to sharpen this point. If we think. I sort of read this as background material in terms of like this, because the questions of frequency often come up and they're like, how light does it really have to be? Because you're gonna do it like once a year, so who cares, right? But if this is actually a set of requirements that is like, no, you have to support like refresh, running the AIC every 2 hours or every day or whatever it is, then actually it becomes quite important to bootstrap from the full public key authentication into a kind of resumption mode. We only do Diffie-Hellman. So like that's a requirement we'll have to sharpen up.
Yeah, I agree. So this would be this would be a full authentication. This could be definitely so by a resumption.
Mohit, so I'm wondering if we can have this possibility where the server or one of the parties can decide on how frequently this is done. If the server, for example, knows information about the device, whether it's battery operated and cannot do key refresh, let's say more than once a day or once in a week, it can choose, and then the other side has to kind of follow that.
Yeah, that's a good point. That if there is, that definitely needs to be agreed somehow, either in band or out of band. Yeah.
But or what I was thinking is one party is the one that decides how frequently this is done. At least in my mind, it would be the server that decides how frequently this update is done based on information it has about the client device.
Yeah. But I don't know. The co-op server might be the constrained one. So it's, I don't know. Client server is, but one of the nodes, yes.
Tero Kivinen. Doing the rekey is actually, if say somebody does IPsec in 1 hour, that's very frequent. I think more common is 8 hours in VPN environments, and this is not VPN. This is very low bandwidth, low message count. I would expect them to do rekey very seldom, like once a week or something like that. And we have to think about what are we protecting against. I mean, if you are sending 10 packets during the week,
yes,
what is the benefit for attacker to actually be able to decrypt those? And the next question is that in some cases the keys are network wide. We know, so of course, one of the benefits there is to do frequent rekeys is that if one of the devices is stolen and the keys is extracted from the device, but then the rekeying is much more expensive than just one Diffie-Hellman, because you have to talk to each other. You have to wake up every device in the network to change the key. So it's not that easy thing. And in, for example, IPsec, we decided so that we had in version 1, we have all of this, we have to do rekey every 8 hours, we have to do this, and it was negotiated. And then we decided that it's actually completely bullshit because we don't need to do that. Either end has their own policy. They decide when to do rekey. They can initiate rekey whenever they need it, and they might have a completely different policy. So one end might say that, okay, I do it every hour because I can do it that, and the other one says, okay, I do it after the 4 gigabytes. And whichever, reaches first, he's going to enforce it anyway. The one who has a lower policy is going to enforce it anyway. So that's going to be similar kind of things would be used here.
Yeah, that's a good point. And not meaning that this is taken as a counterexample to many IoT devices today that use a PSK, don't do Diffie-Hellman, and then they use that PSK for 10 years until the battery dies. So, yeah.
Mohit, I agree with Tero. Maybe we shouldn't set a time, but rather one side can offer and the other side can always reject.
Yeah. And the policy might not be time, it might be number of encrypted data also. Yeah. So a lightweight AKA reduces the network formation time for example, 6-dish. We have a lot of, typically you deploy a number of devices and they all want to connect at the same time. When they reboot, you want to have them to quickly reestablish security. Yeah, and key renewal we already spoken about. I think that is a summary of the requirements document as it is today. There's still a lot to discuss and to specify better, but I think it's a good start.
Okay, thanks, John. You can sit down for a minute or not, or whichever you like.
I can sit down.
For a minute, yeah. So what we're planning to do is just find out how many people have read this, see if there's a sense in the room that we want to adopt this, ask a couple of questions just about process. Do we want to use GitHub issues, that kind of thing? And then kind of have at the actual substantive requirements discussion and so on. So is that okay, Eckert? Do you want to?
Yeah, I think so.
So do
Well,
you
I
want to
guess-
say something before we do that? Or?
Are you gonna? Yeah, are you taking hums? Because I think maybe like some predicate questions before you do that, or did you want a discussion?
Discuss on the topic of adoption. Yeah.
Yeah, exactly. Yeah. So I
Go
think
ahead.
I guess so I think this is a good start. I agree with John. I think and I guess I think the process question I think I'm about to hit is like, because we're not publishing an RFC, we're gonna have some point where we're like, hey, this is like done, and then we're like starting to do a selection process, right? So I think that I want the question then is like what the hum for adoption means, and the hum for adoption means the conventional thing, which is that this we're taking this on, it's a good start, it becomes a working document, and we work on it for a while, and then at some point in the future we're going to have like a discussion about, is this done enough to do a selection process? Then like, let's adopt. I'm in favor. If the hum is, hey, this is like ready to selection process, then I'm hummed down.
Sorry, can you repeat the one you don't like?
If what we're humming for is, oh, this is done enough to start doing a selection process, then I'm not in favor of that. But like I said, I think it's a good start. And if the hum is, let's take it on as a working document and then refine it for a while and then decide when we're ready to select, then I'm totally on board. Things right.
Yeah, we're in your happy mode.
Yes.
Yeah, so it's the first one, the one that Becker likes. Okay. So any other questions about that before we're gonna have a home? Just if first, actually, I'd like to. How many people have read this document? Dozen, maybe more, including previous versions. Does that get any more? This one. Okay. Okay, so there's about a dozen or so. Great. So we have a home to say, do we think this is ready to adopt as that's with the caveat that Ecker had, that we're going to work on it and then do a working group last call type thing later before we do any selection.
I wanted to add, we had 2 more on Jabber.
Thank you. So the question would be, do we want to adopt this draft? And then there'll be a hum yes, and then a hum no. So if you want to adopt this draft, please hum now. Thank you. If you think we should not adopt this, yeah, do you want to tell us how many, Jabber?
+3 in Jabber to adopt.
Thank you. If you think we should not adopt this draft, please hum now. And nothing in Jabber that I can see, no? Great.
Sounded silent from back here.
Yeah, me too. That's great, because if that had gone the other way, we would have had to panic, because who the hell knows what we'd be doing for the rest of the day. Great, so we're going to do that. How do people want to handle kind of issue tracking or anything like that? Do we just use the mailing list, or do people want to do other things like with GitHub and issues? Please give us your thoughts.
I mean,
I would like GitHub.
Okay.
+1.
A couple of pluses, and so to use the issue tracking in GitHub. Yeah. Is that a
Yeah,
clear-
I would at least prefer if we had issues recorded in GitHub so I could like pull up a list of what's outstanding. I mean, as far as discussion of issues, I'm happy to have that on the mailing list or in GitHub or whatever.
Okay, so we'll cause that to happen or find somebody to do it for us. I think that's the only processy type thing for now. So now I guess the question is the discussion of the actual requirements. So John has a couple more slides on that. We've gotten some mail from Ecker recently, so there's probably a couple of topics to bring up. So we'd like to have discussion of those now, please.
Oh, okay.
No, now as in the next, 45 minutes or so.
Okay, I'm sorry. You want to drop this first, or do you-
Yeah, may as well let him finish the slides first, yeah.
So are there any ground rules we want to set up as we're teeing up the topics about how to field questions?
For
The
example,
answer is no as well. I mean,
I think the answer is no, but I'm not quite sure what your question was.
I'm just asking because we talked about clarifying questions. We did not really kind of follow that. So is
I
it
know, all bets are off. Go for him.
free
now.
for all?
Yeah.
Yep. So these are discussion topics, mostly from Kartik, posted on the list in different. One about static DH requirements. Then Kartik posted a review on different security properties. Ecker posted a review today, or at least comments. These discussion topics has not been updated to cover that, but I think we have time to discuss. Yeah. Yeah. So one discussion is, shall we use static Diffie-Hellman keys and then how. This was something me and Göran started working on in the ad hoc document before summer. Then Kartik posted on the list that this is independently, that this is a good idea. And for the latest version of ad hoc, we included that. Ad hoc is used here as a reference, but it's not essential for the discussion. And the reason why both we and Kartik think that static Diffie-Hellman keys should be, it's more a solution, but why it should be considered is that it significantly can reduce the overhead when you use asymmetric keys. And this is especially when you use RPK, the relative differences between signature, aka, and the static Diffie-Hellman, aka, is substantial. So here, as an example, these are the examples from the ad hoc document. So here is the RPK with signature, and here is the RPK with static Diffie-Hellman keys, and you almost get down to what you get with the PSK.
Are you assuming CCM 8 here?
Not ad hoc is using that, but this doesn't assume anything. No.
Well, I guess right. I think so. I think there is there's a consideration here, which is that the certainly in TLS, and I think in ad hoc as well, the negotiation is partly protected via the signature over the transcript, and so the and so an attacker can't downgrade your symmetric keys. However, in this mode, the only signature protection is provided by the symmetric cipher suite. Yeah. And so basically in so if you're using CCMA, then you only have 64 bits of security against anti-downgrade, right? And so so it seems like basically, and that's perhaps less of an issue in the signature modes, I say, because the way ADHOC's designed, it certainly would be in TLS, like I say, but I'm not sure. So I guess I'm nitpicking because I think you obviously get a substantial advantage with Diffie-Hellman than you do over signatures, but I'm not sure it's quite as large as this. Because I think you'd want to use like a 20 octet or 32 octet MAC rather than simply the 8 octet MAC. At least for the transcript MAC. And I think what that actually brings me to, I think, is the bigger point, which is what the requirement looks like, which is what is the sort of the sort of UC guarantee, the UC or CR or CK guarantees of the AIC versus the guarantees of the transport protocol.
Yeah. I think bigger MACs can be discussed in general also for any PSK mode. Do you want the same length of MAC in the authentication as you want in the later in the application?
I'm concerned about that as well. Yeah, I think basically that having an AIC where the only security for the anti-downgrade is provided by the channel, but application security transport gives you extremely weak anti-downgrade defense, right? Because it means that you're basically only as strong as the integrity check on the record layer. Whereas if you have whereas you have either signature of the entire transcript or you have a strong MAC of the entire transcript, then you're strong even if you have an extraordinarily weak record layer. And I guess the hypo here, right, is imagine you had like a record layer with like no integrity check at all, or you had one with 32 bits of integrity check. So now you have no anti-downgrade at all in the PSK case. Whereas you would in the RPK case. Again, assuming you sign the whole transcript, I think ad hoc does.
Yeah, it might be reasonable to allow different MAC sizes in the different, but it also, I think, I said 54 before, but I think 45 is the number in close to the available payload size in both LoRaWAN and 6-ish with 5 hops. So it might be if you go to a 16-byte MAC in the PSK, you need to change to 2 frames. Then the question is that it worth? Worth it?
I think I guess I mean, so I guess it's also important to distinguish between the transport level MAC and the AIC level MAC, right? So some protocols I mean, I think so it's quite possible to say, look, we're just going to absorb an extra MAC only in the handshake messages, but we're not going to absorb it in every message. I mean, and so one advantage of that is then you can have extraordinarily disparate security values for the handshake and for the transport layers.
Yeah.
So is that issue captured somewhere in one of the mails that somebody sent or in the document? I don't.
I don't think so, because because I didn't. I mean, the document is any downgrade, right? It doesn't really define what any downgrade is, and so now I can file an issue when this is.
Sure, I was just going to ask the minute takers
to clarify what any downgrade really means, because it's a somewhat subtle. I mean, so I did note in my comments that any downgrade doesn't apply to the authentication scheme, because obviously the authentication is preventing you from being downgraded in the first place. But so it's important to clarify what any downgrade means, and what it defends against and what it does not.
Right. And Tero, I don't know, did you capture that in the minutes? Try. Please. Thank you.
Yeah.
Yeah.
Yeah. So basically, with static Diffie-Hellman, as Eko already said, the signature is basically changed to a MAC. And there is numerous different ways of formatting the messages and doing key derivation, but that's not important for the requirement discussions. But I think the important discussion here, should we work on a solution that supports static Diffie-Hellman keys, especially for PSK, for RPK? And my feeling and the feeling from Kartik is yes, we should. I think the solution needs to Kartik's suggestion was that maybe we can only do static Diffie-Hellman key. I think that in some theoretical sense that would be good, but I think we will probably need to support PSK. 6-dish is today built on PSK. Signature X509 signature is typically based on signature keys. I don't know if all CS support Diffie-Hellman, static Diffie-Hellman.
Yeah, I agree. I think we should. I think that
there was somebody else at the mic line before you.
Dude, I was at the mic. No, what I was going to say is I wonder if there's an underlying extensibility requirement. I mean, there's some semi-static drafts in the TLS working group right now that are basically taking advantage of the extensibility that TLS has in the signature types and in the public key types you can put in certificates to make it quite seamless how you can take what was originally a signature-based protocol and swap out signatures for semi-static MACs. So I had a general comment about extensibility, but it seems like ensuring we have extensibility in signature types and public key types might solve this problem for us.
I think that's probably true. I was going to say something different, though not necessarily conflicting, which is I think we clearly are going to need to have both signatures. We're clearly going to need signatures to work. There's going to be way too many cases that people are not going to have Diffie-Hellman keys, right? And I don't think and I think it'd be good to support static Diffie-Hellman. I think it would be okay. I mean, we got 6 months ago when we decided to charter this, we weren't talking about static Diffie-Hellman, so we thought it was good enough to signature. So maybe it's not a hard requirement, but obviously and we're going to get to obviously the size issue earlier, but obviously it gives you a substantial size advantage, so it'd be really good to be able to support it. And I don't think and I don't think it makes sense to only. So yeah, I think that would be good as well support it. RPK. I was going to say. Yeah, I think so. I think we should support both. This is correct.
Yeah. So yeah. So it seems to be. I think the hard requirements is probably to support PSK and certificates with signatures. Then static Diffie-Hellman keys come from requirements to try to optimize the message overhead as much as possible. Then second bullet here is how much flexibility in using different types of public key credentials we should allow, and what are the requirements for that. There's been requirement. Michael Richardson has expressed that he would like the solution to support mixed RPK certificate authentication. So one party authenticates with a certificate, one party authenticates with a RPK. I had a picture of that earlier. If you believe then that static Diffie-Hellman keys will be used with RPK, then you would probably also want to support signature in one direction and static Diffie-Hellman keys in the other direction. But that's more what follows if you use static Diffie-Hellman keys. No comment? Yeah. Then second part here of the discussion item is raised by Kartik a couple of weeks ago. He commented on the protection of the PSK identifier. And in his comment, he took current ad hoc draft as an example where the PSK identifier is revealed, not confidentiality protected in message 1. TLS do the same thing. And the question here, what should the requirements about this be? So what Kartik suggested was to move the identifier for the PSK to message 3. Then you can hide it against active attackers. But you run into other problems which might be worse than the confidential of the PSK identifier. So if the protocol suggested by Kartik, then at the end here of message 3, party V is not authenticated. Then you need to add more messages, other AKA or application layer. And if you do that, then you don't really have a 3-message protocol anymore. Okay.
I'm assuming, do you have another slide on this?
What?
Do you have another slide on this?
Yeah, following up, but I don't know, depending on what you.
Well, I'm sensing, I may be getting ahead of you, but I'm sensing your recommendation is we would not do this. That's mine.
Yeah, I think that should probably, for practical, it would be good to have, but for practical reasons, probably it will stay as it would be good to have. Yeah.
Yeah. I mean, I think my concern is it distorts the protocol quite a bit. And it makes it hard, as you say, but you got a 3 versus 4 message protocol. Also it means that some things you might want to do. So you alluded earlier the idea of having application data carried along with these messages. And sorry, can you go back to the either one of any of the public key protocols? Yeah, perfect. So in this protocol, right, anything that V sends to you in message 2 is authenticated. So it's 05 RTT traffic. However, and that would also be true if you had the PSK identity in message 1. Yes. But now in this case, that is not true. And so now I have a protocol like wildly disparate, like security properties depending on where you stuff the PSK. And so I think that unless we have we're tasked to do requirements. So if someone comes to us and says, SICTISH or whatever, says we absolutely have to have this property, but we've gotten pretty far, in the IETF without recognizing this property. And I think this is going to make our lives pretty miserable. So I'm not in favor unless someone comes and says it's a hard requirement for their application.
Yeah, I agree. I don't think we should expand this to 4-message party for this reason. If there's any other reasons to expand it, then this can be discussed. But right now, I don't think so. Then next slide is, so this is following up. Kartik sent a review of the requirement draft a couple of days ago. I think it was probably Monday this week. And he suggested that the requirement draft describe the desired goal of identifying information in general. And he suggested 4 different levels, where level 0 would be all identifying information should be protected against passive network adversaries. 1 is information from one device should be protected from active network attackers. And 2, both information from both devices, active attackers. And identifying information must be deniable, repudiable, even if the peer is malicious. And yeah, going back to, I think it's good to clarify this stricter. I'm not sure this protocol will reach even 0 based on the discussion here with the PSK. That is, and depending on what you count as identifiable information, but in general, the PSK identifier would be identifiable information. If you send what kind of algorithm you support, that might be identifiable information. If you use, if you send sender IDs or TLS connection IDs, then whatever number you put there might be identifiable information. So I think already 0 here might be too strong. Yeah.
I agree. And I don't actually understand point 3. That seems like actually quite a strong property, and I don't think any signature-based scheme meets that property. So I mean, the Diffie-Hellman based schemes do, of course, because either side can force the transcript, but the signature schemes do not. So I think this hierarchy is quite weird. My impression is that, like, essentially every IETF protocol, every IETF 8 anybody's ever designed has essentially the same properties here. Well, except for TLS 1.2, which have even worse properties. So I think, like, we've kind of got a consensus about, like, what these are look like, which is to say, we don't worry too much about fingerprinting of the initial messages, and we try to do the protection of the identities the way you describe in your document, which is to say that the initiator's identity, the responder's identity is secure as passive attackers, and initiators against active attackers. I think that's the right set of trade-offs, and I think that's what your document says. So I think, like, I'm not sure we have to make any change here.
Yeah. What I agree with Karti is that we should document the requirements or properties that we want in more clear way. I agree with Ecker that we should probably not choose some of these. These are good, but these properties come with trade-offs that goes probably against the lightweightness. I think the main thing we want to achieve here is lightness. We don't want to create the most theoretical secure protocol. It should definitely be very secure, but we don't. I think these might go too far, or for practical reasons. For example, protecting the identifier of the PSK comes with a lot of other trade-offs in number of messages. Then third part of this discussion is security properties and properties of the application data. We got a request on the next slide, comes application data. Got requests from academia to try to specify the security property of this in the requirements draft better, so any solution documents could be formally analyzed and check if they meet the requirement document or not. Then Kartik, this Monday, he sent a list with the requirement document contain a lot of security properties. Cartex came with suggestion how they should be made more strict and clarification and some small changes. First, so this is taken from Cartex mail. So PFS against key compromise. Cartex acts against what material? And we want loss of the long-term key from the initiator and the responsor, loss of the ephemeral key initiator responsor, bad RNG. And I would say definitely the first, probably not the second and the third, but I don't know if you can easily, if you very easily can get protection against the bad RNG, sure, but I don't.
Yeah, this is like Carthag's advertisement for Diffie-Hellman, right? Is what this is about. One, as you say, we already any sensible protocol will already have. Two is like super hard. It basically requires having there's two ways people typically do it is with these Diffie-Hellman protocols where you say like that that you mix in the static key and therefore ephemeral keys compromised. That's like there are environments that's like sensible, like where the static key is like stored in a box and the ephemeral key is not. But in like these environments, they're like in the same, like they're like adjacent regions of memory, so I'm not really worried about it. I'm not worried about it like beyond like the obviously I'm worried about it, but I mean like I'm not I don't understand the scenario in these environments where like you lose the ephemeral key but not the static key. It's, the other one's much more likely. The bad RNG, the good news is we already have a fix for that, which I think Wood is rising to discuss, which is the CFRG draft about hardening randomness, and that's totally compatible with the signature-based protocols. So, but the good news is it's a compatible protocol change. So I think we don't need. I think we should just I think we should stick with number one is obviously a requirement. Number two, we should do nothing about as a requirement. And number three, like when we finally get around to writing document the protocol, it should like say why don't you? It should suggest you use that CFRG draft.
Yep.
Yeah, Chris, just to expand on that, the basic idea of the CFRG draft is you take the long-term private key of the responder in this particular case, and you compute a function of it, and you mix that with the output from your RNG. And then the security of your randomness is the minimum of your bad RNG or your private key. So if your private key is exposed and you have bad RNG, everything's over, everything's bad. But if you have bad RNG and your private key is fine, it's all as well. So I would just take a look at that draft, and it's easy to do, it's compatible.
Yeah, seems like it's compatible with any solution protocol. Yes,
it's very protocol agnostic.
Yeah, sounds great.
Hannes, the first two, it depends a little bit, of course, on how you implement these type of things. Currently, what I've seen people doing more and more is to separate out the key exchange implementation from the way how you handle the key storage. And so if you can properly protect the long-term key, you will already have the things in place to do the protection of the ephemeral key, because you just make calls and then basically use the keys as kind of opaque keys. That's what we do in embed DLS. We actually separated those out. You can actually look how this is done in our code. I haven't done a survey on some of the other embedded implementations, if they actually allow you to do the same or whether they gloss over that issue. It was a fairly substantial change in a way how we did the APIs, but it may be if someone has some spare cycles, some researchers here in the group, they could actually take a look at this. It would be really interesting to see how this is done and how actually make some recommendations to improve it. Like those would be practicals in terms of what people deploy today.
So, Hannes, just as a question, when you did that work, were there any changes you wish would have been made to protocols to make that better or easier, or is it all just implementation?
There wasn't really anything we used that obviously with DLS, so we didn't have to do any changes on DLS. It was just the implementation on the way how we pass around the keys. And there are obviously, if you want to take into account not just the software use or the software storage of the key, like purely in software handling, but rather cryptographic modules, then those typically use different APIs. And so making the API to work with all these different designs was a little bit tedious, but yeah.
Thanks.
seems to be agreement here to do 1, not focus on 2, and reference the CFRG document for 3. Then here there was a request from academia to specify more clearly the properties of application data. Here is a suggested formal requirement for the AD, but that also, this depends a little bit on how many messages the solution has. If you have a typical 3-party protocol like Sigma I, then you get the first message is completely unprotected. Second message is confidentiality and integrity protected against a passive attacker, and what you can put in message 3 is confidentially integrity protected, and you know who the other party is. This can maybe be specified more clearly. Ecker?
Yes, that doesn't sound quite right. I think AG2 has confidentiality against a passive attacker, but integrity against an active attacker. Because at least in Sigma I, the G to the Y is authenticated in message 2, and therefore, assuming the initiator, got the proper G to the X, then then he has integrity for the data that came from the server.
Yep.
Okay. Other than that, I believe you're correct.
Yeah.
Okay. Yeah. I think this seems like right otherwise.
Yeah. But basically, this is for a 3-message protocol. If you take Sigma R, for example, then you get unprotected, 2, 3 here. If you take Cartix protocol and add something, then you get unprotected 2, and then 3.
Yeah. Right. Exactly.
Twice.
Yeah.
So there, yeah.
Right.
So,
right. I'm thinking Sigma I. Absolutely.
Yeah, but I think
John, is the authorization request, does it contain just, is it kind of only a, here, please give me, or is there, please give me, and here's a nonce, here's some other stuff? Like what's in the authorization request? I think because I'm looking at this through sort of like the eyes of OAuth, and I noticed like the whole dance, the information you carry in each of those tends to be quite important for the overall security. It's not just, if you think about the access token request, it's not just, oh, give me an access token. There's more than that.
Yeah.
Is that, do you assume that
I think
this
is just an example how you do would send a certificate request in security protocol. I think what 60s want to do is to send a token containing the actual keys to use in the security AKA. Is that correct?
So this is not OAuth, like authorization tokens?
No, this is just an example. I think sending some token in request 1 with the actual key to use in the AKA has been discussed.
So this is a profile of Brewski that we've been discussing, and Hannes, this is a profile of Brewski and Anima that we've been discussing, and essentially in AD1 we discussed the sending of the voucher request and getting back the voucher as in AD2 essentially.
So I think this needs what type of information people want to send in different messages should be discussed. Simplest, it's completely independent of the AKA, but I think in some cases you want to send a key to use in the AKA in an authorization token. There might also be so that the authorization token, when you use that, you want to reuse some of the randomness from the AKA, for example, to save overhead. So there, yeah. So in the end, they might not be completely. It's important that whatever you send in the application data does not violate the security property of the AKA. So this needs to be clarified. Yeah.
Yeah. That actually brings up an important point when about potentially key separation. In the second message especially, right, you want to use different keys to encipher the application data and to encipher the handshake data. So I mean, I think I'm not sure. I'll think about how to document this. This is something we sort of struggled with, as you remember, a lot in TLS, how to like write this down, but and didn't get it right because of NST entirely. But so I think, but trying to like, there's a lot hidden under those last two bullet points, and so we should probably figure out how to document those better.
Yeah, I think typically what you send in messages would be protected completely independent of the AKA. In message 2, I agree, it makes sense to have different key, but that would probably also lead to 2 max, which we might not want to have, and then it might not be
right. Yeah, I think we're going to need to talk about like what kind of like CK guarantees that the system has to have.
Yeah. I think that's it for this discussion. I don't know if there are any other discussion topics that people want to have. Otherwise, it's the 6-ish thing.
Well, okay, we have like 20 minutes, so the 6-ish one will probably take 5 minutes. We want 5 minutes maybe to talk about whether we want to have intro meetings and stuff like that. So I think we have like time now to bring up other issues.
Yeah, I mean, I think that one thing that I think we're gonna need to spend a little time on is like trying to sharpen up the sort of like frontier what's possible. I mean, like the I mean, as I sort of expressed, I got a little discomfort with the sort of like as small as possible. And if while it is true, obviously every byte costs, they're like, we know there are cliffs, and like trying to understand like, where those cliffs are a little bit, I think is gonna be helpful, because like, I just like what I don't want to do, like we're seeing this in Quick right now, is like, it's like there's a lot of fighting about like how much screwing around to do at the very end. And I sure don't want to be like a working group last call and have like a charter that basically someone says, well, I can remove like, like one octet, and like, and the charter basically tells us, oh my God, we got to like recycle. So I'm just trying to get a sense of like where the, like I think we spent a little. I mean, this is the work of the working group, so that's great. But I mean, like, spend some time trying to like document what the requirements mean in practice.
Mm-hmm.
Sorry, I wasn't clear. What's the action following from that?
Yeah, the action. I think the action is, and this was in my review a little bit, is that we need to figure out how to like sharpen up the size requirements.
Oh,
that's all.
Yeah. Similar as to something I expressed a little bit earlier, I think that I'm not totally sure exactly what form this needs to take, but I feel like there should be some requirements in here around extensibility. Right. Clearly, we need a certain degree of cipher agility at the very minimum. Maybe some other forms of extensibility. But I'll try and think about how to put that more precisely and send some feedback to the list. But
yeah,
glad to think about hear what the authors think as well.
Yeah, I agree. That should be added if it's not. There should be possible to add new algorithms, maybe new ways to authenticate, maybe new ways to identify credentials, and so on. Yeah.
An interesting thought experiment might be this PAKE question that came up earlier. Like, it might be that in an initial version of whatever AKE we come up with here, we don't have a PAKE flavor to it, but it might be nice if there was sufficient extensibility in there that a PAKE could be fit in later. But again, I'm not quite sure how to express that in like requirements language.
Yeah, no, but that's a good point. Concerning Ecker's comment, I think right now the document does not, it has a lot of discussion about the radio protocols. It does not have numbers, but I think there are numbers that could be put in, numbers that was discussed during the both presentations. For example, Laura Bond, if I remember correctly, you have to make assumption what kind of transport protocols you have in and what options you have in these and so on. But I think number 45 came up, something like 45, maybe it was 47, for a single message. I think there are similar numbers for 60 if you assume 5 hops which might be a good assumption, should probably discuss, but there the number of bytes available for the body decreases for if you have more hops, it increases if you have fewer hops. NB-IoT is more flexible, then you don't have a very fixed frame size. So, but every byte you save saves energy and latency, and creates less lost messages.
So like we do have a few more minutes if there are any other topics people want to bring up on the requirements document right now, or seems like not. Oh, Francesca.
From the Jabber, Yaran says, John, one question from both Kartik and Ecker was, if post-quantum is a requirement, is this a good time to discuss that?
Yeah, my view and Göran's view, which we posted to the list, is that it should be possible to extend it to post-quantum in the future. I don't think the focus right now in Lake should be post-quantum key exchange.
Yeah, I mean, I agree with you. I think, we've spent a lot of time screwing around with like trying to reason out post-quantum, and we're nowhere near. So there's two questions, right? One is post-quantum key exchange, one is post-quantum authentication. But I don't think we're ready for either of them. I think I think as Richard was indicating, what we need to do is a suitable amount of sensibility so that if and when we want to do that work, we can do it.
Great. Thanks, John. So Malaysia's going to present on behalf of Michael, who's got to be elsewhere. I don't know, you got the clicker?
Yeah, I got it. Yeah. So these requirements have been brought up over and over again. So I'll just go quickly. I think John mentioned them already quite a few times during his presentation. So there shouldn't be anything controversial. So there is this document in the 6-ish working group that specifies that we call zero touch join, that specifies essentially an enrollment solution for 6-ish. That is the document is a profile of Bruce key, of constrained voucher and constrained voucher documents in Anima, and also of the ESP over CoAP-S document in ACE. We essentially here wanted to minimize the overhead of what goes over the wire during the exchange. So we've been discussing these requirements, and essentially on the first slide, this doesn't wish to have DTLS frame overhead. This frame, does that refer to the record layer or record layer frame, or is that
Michael did
or
the slides.
DTLS at all?
I'm not sure. Michael did the slides. I think he refers to the message overhead of TLS, but
Okay.
we will need to confirm with him. So I'm just presenting on behalf of him.
Yeah, because the ACE, for example, the ACE document that you point out, that's obviously intentionally designed to have ESP over CoAP-S.
Yes.
And so if you don't like the TLS, then maybe Michael should have not picked the ACE work. But
Yeah, it makes sense. So a couple of requirements there that have been brought up on the list before. Essentially, we would like to send certificates by reference rather than by value over the wire. We would like the two peers in the ACE run to be authenticated by different types of credentials. For instance, one use case that we discussed is the server being identified by an RPK and the client being identified by its IDEV ID, which is a certificate that it uses to enroll into a new domain. Yes.
I'm not quite sure I'm following the second half of that second bullet. So you say server can identify by RPK, which needs to be sent to a client, so you can put in the voucher request. What does that mean?
So it means that essentially the client needs to receive the RPK over the wire.
Okay.
Yeah, and that it doesn't have it initially because it discovers the new network, the new domain on dynamically.
I see. Okay. So the RPK is carried over the wire.
Yeah.
A la what, 74 520 or something, right? Okay, thanks.
Yeah.
And so that means the client. So I guess then how does the client authenticate the RPK?
I'm not sure.
Okay.
I will need to discuss with
Okay.
I'm not sure. Yeah.
This is a salient question because because if the client authenticates the
I'm sorry. Yeah, obviously. There is a third party involved, the authorization service, that certifies of this RPK. So essentially, in the voucher request that client sends onward to the authorization service, it includes the RPK that it received.
okay. So
And then there is an exchange coming from the authorization service where the authorization service vouches for this RPK to the client.
right, I guess.
Okay.
But I guess then I want to push back on this. Then I want to push back on this requirement because it seems to me that a better design would be for the server to send a digest. Why doesn't it like my point is why is that instead of having the server send the client the RPK, which the client then asks some Oracle, it gets a 1-bit response back. Wouldn't it be better to have the server send the client identifier for the RPK, and the server calls the Oracle and gets the RPK back?
Yeah. So my response would be, I mean, this is a profile of Brewski. This is how they've done it.
Okay.
Yeah. So
Okay.
I mean, I have no other.
Oh, okay. I'm just, but I think it's relevant. Okay. Well, we were talking about it separately, but it's like, said what you're trying to save bytes in the wire at this interface. Like this is like not this is like you just burn 32 octets, right? So that matters.
I do not understand the last thing that you said.
Okay. So I think one thing to recognize is that I don't know exactly what sort of network topology you have in mind, but in some of these topologies, you're going to have this air interface, which is extremely low bandwidth, and you're going to have, and I don't know how you're talking to the server you do the voucher request for, but if that's not over the same air interface, if it's like over a wire, then you want to move data from the air interface onto the wire. And so this RPK is 32 octets or so, right? And so, if assuming it's F25509, and so if your interface to the voucher server is faster, then what you want to do is you want to have an identifier here, and you have the voucher server give you the RPK, so you just save those 32 octets.
Yeah, that makes sense. Yeah.
Mohit, can you go to the previous slide? So this third draft in the list, are you sure it's ESP and not EST? So is it encapsulated security payload or enrollment over secure transport? Because I'm confused. Those acronyms refer to different things. So someone, Dan in the audience says it's EST. So that draft is incorrect. That kind of confused me. What would help here is for you to say that our requirement is that the AKE should support where the client has device certificates and the server has RPK. So kind of having this high level, because otherwise I was confused with just the first two slides.
Yeah, this is essentially the summary.
Just saying that we start that the client has device certificate, A221AR certificate, and the server has RPK, and then we want AKE to magically give us session keys. Perhaps that's an easier way to frame the requirement. Second, I'm not sure we should get too much influenced by this requirement when we are designing our AKE, but that's just my opinion.
Okay, thank you.
Great. That's that. Great. Okay. So a couple of questions. In terms of the draft adoption, we'll confirm that on the list. Do people prefer to get another revision of the draft before we do that call for adoption, or just go ahead and do it? Just go ahead and do it is what people are saying. Great. So we will. Yeah, I mean, I've got to check. And do people want to, in terms of working on this, we're going to use GitHub and issue tracker, the issue tracker there and so on. Do people have a preference for virtual interim meetings or what?
Roman, yes, virtual interim between now and 107.
So yes, that you would attend, or yes, as an AD, you think it's a great idea?
No hat, yes, I think it's a great idea.
Okay. So any other people seem to, so when? I would naturally think kind of like maybe January-ish, but.
So from Jabber, we progressed a lot today, have one in December. Göran and Jim +1 to virtual interim January and February.
Yeah, so we've suggestions there for December, January, February, which is kind of like every month. But December might be a bit ambitious because in terms of people getting home from here and doing stuff and actually making progress. I mean, I think I'd like to try and like open issues in GitHub and then close a few of the easy ones, hopefully, and then have an interim about the things that are worth talking about would, I think, be what I would suggest. So that would be more January than December. I'm seeing the room temperature here is warm, so people are falling asleep or something. Yeah. Good, which is good.
Roman did it. Might I propose that we commit to load up GitHub by early December. We can chew on it. Maybe start talking mid-January, late January for the virtual.
Yeah, that sounds kind of reasonable. Yeah, and we got a thumbs up there.
Göran is suggesting to make a doodle, see if people can attend in December.
Yeah, but I think as Roman just said there, I mean, you know, I think there's a bit of lead time in terms of getting Git issues open, talked about, eliminate the easy ones. So December mightn't be that productive.
Yeah, I mean, don't you need a 30-day, isn't there a 30-day notification, right? It's 2 weeks, okay.
2 weeks, right.
Well, I can tell you December is a nightmare. So, I mean, even now, so what it's the 20th, so we're looking at the 4th, we like the earliest day you could do it. Things are starting to get pretty hairy towards the 4th.
Yeah, so I'm hearing and sympathetic with the idea of trying to get people working on the list and with Git in the next month, and then have a call maybe January and February if needed. Yeah. So. Okay, and I think that brings us to the any other business. Did I forget them? Okay, any other business? In that case, thank you, and we'll see you on the list.
Thank you.
Easy, told you. Yeah. Yeah, that's always hard. Yeah.
Oh, yeah. This is like the new official slide color.
Okay, so here's
That's amazing.
back to the
To the registration desk.